let's get our notes out. And we're going to where we left off, which is on the back of page 12 of your note packet. And we are practicing. Come on, guys, let's get them out.
So, you know, I could just push your fingers.
I'm not ready.
Anybody know anything about rent? That was yesterday. Okay. So let's start with what we had yesterday. We started with yesterday. And that is this random shape. We're only going to do a couple more with this shape, and then we're moving on to the next section. But let's go ahead and review. We had this shape. It doesn't mean anything. It's not special at all. It's just random. Okay, now we're doing stuff to it. So let's look at problem E. I don't think we've done that one yet. And let's talk about what happens to the picture. What?
Oh, it moves to
We already did it.
Oh, did we do this
Yeah,
one?
we did this one because it was the first one that had two.
Okay.
Move to the right one.
All right, let's talk about it again just to refresh, and then we'll go down and do the next one. So what changes happen with this? Flips how? It goes upside down. The negative out in front goes upside down. So let's make a note there somewhere to remind ourselves, because today we're going to get a couple of new transformations, and it's going to start getting confusing if we don't keep track of them. So that one's going to turn the picture upside down. What does this do? That goes right one. So apparently yesterday we grabbed this and we flipped it upside down and moved it right one. Okay? So what about the next one? What does this one do? What does this negative do?
Sideways.
This is a sideways flip. You have to pay attention to where the negatives are in the problem. If it's out in front, we're going upside down. If it's in here, if it's on the X itself, when we draw this picture, everything that was on the left is going to the right, and vice versa. Okay? What about this minus? Down 3. So in these two examples, you can see the impact of a negative and of a minus. But the impact's different in each problem because the negative and the minus is in a different spot. All right, so here we go. Some of you can do all of this in one time. I can't. So I'm going to start inside the parentheses first, and I'm going to flip this picture. So remember, that means we're just moving it from side to side. So this little triangle is going to get drawn over here. And all of that is going to get drawn over here. This is not the final answer. This is just step 1. That's the reflection across the y-axis, the sideways flip. Is that okay with everybody so far? Now I'm going to take this whole picture and I'm going to drop it down 3, which is going to be tricky because I didn't leave myself much room here. I'm going to take everything down 3. So I can use a different color or just mark it heavy and dark. But every point's coming down 3. So everything's coming down to here. So I'm going to have this it is. That red thing is the answer to the question. It's this picture, flip-flop sideways and drop down 3. Do you feel like if you had to do something like this on a quiz, that you could handle the negatives and the adds and subtracts? So one more time before I erase this and we move on to the next section, because we're not going to do every single problem. There's just too many of them. A negative out in front, upside down. A negative inside, sideways. An add or subtract inside the parentheses, sideways shift. And an add or subtract outside the problem, up and down. Right? All right, let's turn the page and look at number 4. We have a different picture, but the idea is exactly the same. But look at some of the problems. We're going to be doing different kinds of transformations. So now we've got a triangle, a semicircle, and a trapezoid. That's our shape. Sean, you awake today? Good. The very first problem says 2g of x. This is g of x. This one's called g. Remember, it doesn't make any difference what letter we use to name it. Any guesses as to what that 2 is going to do? This is brand new. Unless you've been coming in during flex, you've probably never done this before. Anybody know what that 2 does?
Stretch.
What?
Does it stretch?
It absolutely does stretch it. So it stretches it by vertically. It's a vertical stretch by a factor of 2. So what that means is it simply multiplies the height. Whatever number you put out in front multiplies the height. Obviously, if that number were a 1/2, it would be a stretch, Christian. It would be a shrink, right? But that number out in front multiplies the height. It doesn't shift, it doesn't flip, it doesn't do anything except make it, taller or shorter. Okay, so here we go. How tall is this triangle right here in the original picture? How tall is it? 2. So I'm going to redraw that triangle, but now it's going to be 4. It's the exact same triangle sitting right here, but now it's 4. How tall is my little semicircle right here? 1, so now he's going to be 2. And is that trapezoid down 1? Yep. So now he's going to be down 2. And that's all there is to it. So a number out in front multiplies the height of the picture. All right, let's try B. What do you think is going to happen to this one? Tyler, what's on the iPad? Okay, we'll put it down for me, thanks. What's that negative 1/2 going to do? Well, it's going to make it half as tall, but what else is going to happen? So it's going to be half as tall, so this is going to multiply the height. But don't forget, you got this guy. What's he doing? That's going upside down. A negative out in front, even if there's a number, makes it go upside down. So now we're going to have that shape, but it's going to be upside down and half as tall. So, how tall was the original triangle? 2. So now it's upside down and it's only 1. How tall was the original circle? 1. Now he's upside down and only a half. And the trapezoid? Now he's on top, but he's only a half. There it is. Oh my golly. Look at the next one. What's different about it? The 1/2 is by the XM, it says. So the 1/2 is in a different spot. And that changes things. Any guess? The number out in front multiplied the height. Any guess what a number in the front there does, Jacob? Actually, it impacts the width of the picture. This actually divides the width. So sometimes, Jacob, it does squish it, but not this time, because we are going to be dividing by 1/2. And dividing by 1/2 is the same as doing what? Multiplying by the reciprocal, which would be 2. So this width is going to be twice this. A number out in front multiplies the height, a number inside divides the width. Now, at first you're thinking, oh my gosh, Mrs. Ford, how can I keep track of all that? Well, it kind of goes with what we've already done. Because remember when we had this, when it's inside the parentheses, doesn't it go the opposite way that you would think? So when it says -2, it really goes 2 to the right? Well, this is kind of the same thing. Instead of multiplying by 1/2, we're doing the opposite, we're dividing by 1/2. When it's inside the parentheses, you do the opposite. When it's inside the parentheses, you always do the opposite. So, this guy is going to be twice as wide as he was originally. There's no negatives, you're not flipping. He's just going to be twice as wide. Okay? So what does that mean? Well, how wide, and you've got graph paper. You're supposed to be doing this on your graph paper. You've got graph paper, so you got 2 blocks here, right? So how wide is this trapezoid going to be? 4. So 1, 2, 3, 4. He's going to, or not trapezoid, triangle. He's going to be clear over here like this. Now notice he's still 2 up. We haven't changed the height, because the only way you can change the height is to put a number in front. There's no number in front, so it's the same height. It's just twice as wide. This circle right here is 2 across. So now he'll be 4 across. I'm going to run out of room, because the circle's clear over there like that. And then the trapezoid is 1, 2, 3. So he's going to be 6 across. So, sorry about that. I'm clear over here out of the vision. But it's going to look like that. So everything is twice as wide as it was in the beginning. And the reason it was twice as wide was because we put a coefficient on the x, and whatever that coefficient is, it divides. I'm going to skip around a little bit. Let's talk about, still going to use that picture. Let's talk about Y, problem E. Y equals G quantity of negative 2x. Now in a minute, you're gonna come up and do some for me. So let's see how we do with this guy. Let's mark the changes in words. What happens here? What does this do? Look where it is. What's it do? Sideways flip. Remember, negatives are always flips of some kind. So this is going to be a sideways one because the negative's inside. If the negative's outside, it's a flip upside down. What does the 2 do? It divides this number, whatever it is, always divides the width. Whatever coefficient is on the x always divides your width. So that means everything here is going to be half as wide, and it's going to be flipped sideways. Now if you can do that all in one step, it's okay. I think I'm going to do it in 2 just because I can't process all at once. So I'm going to flip it sideways. Flipping it sideways means the triangle's over there, the semicircle's over here, and the trapezoid's over here. So that's my sideways flip. That's the negative. So this over here, all that over here. Okay, now I'm going to make it half as wide. Well, what does that mean about this triangle? If I'm going to make it half as wide, it's only going to be 1. So it's going to look like that. I'm going to get this one out of here because it's too confusing. But would you agree? It's only 1 unit wide. What about the semicircle? It's only going to be 1 unit wide also. Oops, it's supposed to be up 1 now. Gotta still go up 1. We haven't changed the height. And then, oh, now watch this one. How wide is the trapezoid? Well, watch it count. How many squares? 1, 2, 3. Don't count hash marks. Count the actual width of the figure with the blocks on your graph paper. Isn't it 3? Which means if I divide that by 2, that's going to be 1.5. So that trapezoid is going to look like that. Make sure you tack it onto the end of your circle. It's all got to be connected. It's still down 1, but it's only 1.5 wide. Is that okay? All right, I'm going to leave this shape up here, but feel free to bring your paper up. Do I have a couple of volunteers? We'll get a couple more of them done up here. You can come by yourself or bring someone with you.
Oh, wait, you're trying to go.
But let's do F. And F is a double flip. And then, oh my gosh, let's do H, which has a lot going on.
Right.
You and husband are partner? Good. Alright, any volunteers to come up and do, what is this, H? Anybody want to do that for us? It would be great if someone would volunteer. Okay, Will.
Oh, yeah, that's it. Yes, sir. Sure. You went between one of your
I don't know if he's chocolate or vanilla, so
And then what is this?
I'm already in vanilla.
one.
You keep bringing up H.
Yep. So you got three things to do.
Hey, the white boy.
Right, three things. So I would follow PEMDAS.
Don't tell me it's big board.
Yep.
I'm about to smash it.
Big one.
And move everything over right here.
Here's some more.
Except he wipes it in the morning. He's not really one.
Is that one for now?
Yeah, he's not really
He's
white.
more of a, he's up in churches from BD.
But he sounds black. The first time I fixed him, I was like,
The rest of you should not be sitting here doing nothing. Get your graph paper out and sketch along with these
he
folks
really sounded
so that we know whether they're right or not. Okay. Wow, take a look at this one, guys. The boys had to do both flips. They flipped sideways and up and down. So look, what do you think? Did they do a good job? I think it looks really good. Good teamwork. They did both flips, left and right and upside down. Good work. Okay, now wait, why is this only one across? Oh, because you moved it? Okay, now remember, when you move it, it's still two across.
It's like, just like, even though it's the brand.
Is going to
The
be
Costco brand. For the same price.
exactly. I'm like, sometimes just
tack on
to get one of the other two.
But that was no, I definitely don't think it's they're not very big like
and then your traffic
It's four way on the
down.
town.
when
That's enough for a warrior.
it's a start.
He's starting defense. He's a line.
You don't want it.
I think.
She said she like a big one. She like her because she likes her cuts like she likes her because I'm sick.
But I never said he's not even big.
So he's just
He's literally like he's just
so he on that left. That's why he didn't want it. You gotta be.
he's not skinny either.
I
Like,
would-
he's not like big.
What you trying to say?
No, I mean like he's not linebacker.
He's not like
Yeah.
Nobody said
Yeah.
Sean.
You
You
say
know how
play
linemen are
linebacker?
big. Yeah. No, I think it's either lineman or linebacker.
Probably on. I don't know the white.
Okay, are you guys working on this problem? Next quiz we have is going to have all this, plus there's one more set of stuff we have to learn yet.
Oh.
So you need to be able to manage all this. No, take this one straight up right here. And take this one
No, he's
straight up.
definitely on defense.
And take this one up too. So it's gonna be up here, the top of the triangle.
I don't know if he blocks or not.
Yep. Now take these two, lift them straight up. That was already, no, this one's already lifted. You need to lift this one.
Does the player have the ball?
And then draw your semicircle.
I'm just gonna be quiet.
That here, here,
Wait.
here, connect those, and that one. Okay, so these guys had a little harder problem. There we go. So let's take a look at everything they had to do. They multiplied the height, they shifted to the right one, and they lifted it up two. So they got their problem in various stages, but their final answer is this one right here. This is the shifted, stretched, and lifted picture. Okay? Now, it's hard on the board. When you're on your graph paper, it's easier because you can actually count. All right, we have one more kind of transformation to talk about. Let's let's make a little list over here and just make sure we remember what we're doing. Let's look at the negatives. This one does what? Upside down. This one does what? Sideways flip. Alright, then we have numbers multiplied. What does this number do? Multiply height. What does this one do? Divide width. And then we have these numbers. What does this one do? What does this one do? Left 2. And what does this one do? Up 2. Good. Alright, I think that takes care of everything that we have talked about so far. We have one more transformation to worry about, and that is the absolute value. So I'm going to keep this same picture, and we're going to talk about, this is number 5, this is A. We're going to talk about this, and then we're going to talk about this. Now, both of the problems, this is A and B, both of the problems involve absolute value. Do you see that?
Yeah.
But what's the difference? Here, the absolute value is the whole thing, and here, the absolute value is only around the X. David? What, another piece of graph paper? Yeah. If you need more graph paper, it's over here. Let me show you where it's at. And then you don't have to ask anymore. Just come get it. It's right here in this top shelf right here. Okay? All right. Now, when you have the absolute value of the whole function, I think of this as bottoms up. Because when you take the absolute value, you know this from everything you've ever done. When you take the absolute value of something, it becomes positive. So anything that is in the bottom of the picture is going to become positive. So when I graph the absolute value, anything that's above stays above. None of that changes. That's already up. It's already positive. But this guy is negative. He's below the x-axis. These are negative values. So he is going to fold up. That's all there is to it. When you take the absolute value of the function, of the whole problem, anything that's positive stays up. Anything that's up stays up. Anything that's negative comes up. It's that easy. That's it. That's the absolute value of the whole function. That's easy, Sean says. He's right. It is easy. Now, when you take the absolute value of just x, this is the tricky one. It's easy, but you have to remember what to do. When you have the absolute value of just x, you redraw the right side of your picture. So you redraw the right side of your picture exactly as it is. Okay? So here it is. This is the right side of my picture. Redraw the right side of the picture. Okay? Now here comes the tricky part. Then mirror that onto the other side. So in other words, mirror it, flip it over, and draw exactly the same thing on the other side. And that is the answer to the question. when you take the absolute value of just X, you draw the right side of your picture and then mirror it onto the left side.
And so you keep the right side is part of the answer, so you need to.
Yep, the whole thing. The whole right side is part of the answer, and then you draw it onto the left side. Now, the part that freaks people out is they say, wait a minute, Mrs. Ford, what happened to the triangle? It's gone. It's gone. It is not part of the absolute value. When you take the absolute value of just the X, everything on the left of the picture disappears. Whatever is over there is gone. And it is replaced with a mirror of the right side. Okay, a little tricky. Let's try a couple more of these. What about Thailand? Okay, here we go. What do you think? What's going to happen here?
So you flip the bottom.
So this right here means we're going to have bottoms up. And then once we get that done, what else are we going to have to do? We're going to have to lift it up one. Alright, so see if you can draw this. See if you can draw this. And you might be able to do it in one step. I cannot. So I've done this part. I've done my bottoms up. Now I'm going to pick it up one. And the blue thing is the answer.
You want us to erase?
You don't have to erase,
okay.
no. Use a different color or go over it heavy or something so I know which one's your final answer. But yeah, you can do these in stages. Use colored pencils if you want, or just make sure that's shaded heavier, whatever your final answer is. You okay with that? We're going to pick one more of that, and then we're going to do one of the sheets I gave you yesterday. Let's see, which one do you want to do? It's left, E, F, G, or H? G? Oh shoot, I just erased our list, but oh well, you have all that written down, right? Alright, so we're doing G. Okay, so what's going to happen in this problem? So bottoms up and stretch. So we might be able to do that in one step. I don't know. First of all, anything that's already up, it stays up. So I'm just going to redraw that triangle all the way up to 4 because this multiplies the height. And the same with my circle. It's not changing either, except it's just getting twice as big. Okay, now what about the trapezoid though? The trapezoid has to come up because of the absolute value, but then it has to come up, it's got to be taller because of the 2. So that will be the answer to the question. There's a lot of rules to remember. All right, do you want to try any more of those, or do you want to go to our practice paper? Practice paper, all right. So yesterday, or whatever day that was, I handed out a couple of packets, and one of them said graph practice. One of them said graph practice. So get the paper that says graph practice. says graph practice at the top. It says graph practice 1, because the second page says graph practice 2. Huh? Alright, so yeah. Alright, this is part of your homework. This will be due. So if you want to just go ahead and like start filling it out, that would be great, since you're going to have to turn it in. So again, we're not going to do every problem. Tessa, look at the front of graph practice 1. There are 7 questions. Pick a couple and we'll do them. All right, let's start. Wait a second. Well, let's pick another one, honey, but let's get number 4 done first. So this picture that we are using as our basic picture is that trapezoid. This triangle. And this triangle. Okay, so that's our base picture, and we're going to do problem 4. Okay, well, take a picture of somebody. They were handed out at the same time. So, you, Tessa, you don't by chance have 2 of them, do you? Okay, because I probably gave them to you and you passed them down to him. So you can just write them down off the board, or take a picture and put it in the book. Yeah. Okay, so here we go. What does this look like? What happens in this picture? It's a negative, so it's a flip. Sideways. So this is going to be a sideways flip. So this is problem number 4. And all we're going to do is take this little trapezoid here and move him to the other side. And then take these 2 triangles and move them to this side. We are not changing the shape or the size at all. We're just flipping from one side to the other. What are you doing? What are you doing? What is so pressing? Well, I appreciate that you have an anatomy test, but you got to pass this class too. Okay, so that's number 4. Tessa, you good? All right, pick one more, Tessa. Number 3. She wants to do number 3. All right, what happens in this one? Left one. So we're going to take our original picture, always go back to the original, and we're going to move everything left 1. So our trapezoid, instead of starting at the origin, is going to start over here. So there's our trapezoid, left 1. And then our triangle and then our little triangle. So Tessa, when we put a number inside the parentheses, adding or subtracting inside the parentheses, it moves us left or right. So +1 actually goes to the left. All right, let's do one more from the front side of here. Elliot, pick one. One more that we haven't done from the front side. 6. This is one that we just talked about. I'm going to do it down here where I have a little more room. This is one we just talked about. Who remembers, this is a tricky when we have the absolute value of just X? Left side disappears. And what replaces the left side? A mirror image of the right. That's exactly right. So first I'm going to draw the right side of my picture exactly as it is in the original. No trickiness there. Just draw that right there, the right side. And then mirror that over here. That is problem 6. Everybody okay with that? All right, let's turn it over and look at the back of that page. We're going to use the same function, but now there's a bunch more stuff. So, Mamuna, pick one from the back, problems 8 through 15. What do you think? Nine? Okay, let's look at 9. 2 things are happening in 9. What are they, Mamuna? What is happening in problem 9? What is this going to do? I can hear you. Shift it which way? Left 1. Yep, this is going to go left 1. And then what does the absolute value on the whole problem do? Bottoms up. That's right. So we're going to move it and flip it up. So here we go. Everything's going left. Seems like I just did this. Everything's going left. So our trapezoid went left. And our triangle and our other triangle. So there's step 1. Everything went left. And I did that first because I'm following PEMDAS, the rules of PEMDAS. I'm inside my parentheses first. Now what does bottoms up mean?
The bottom goes to the
If
top.
it's in the bottom, it's going to go to the top. So this is in the bottom, so now it's coming to the top. So now my trapezoid's up there. This is staying put, so that's fine. But this has to come up. And that's it. How do we feel about that, okay? All right, let's do one more from that side. Jacob, you want to pick one?
Number 14.
14. What's happening in 14?
To the right.
The picture is going to go to the right too. So it's just the shape. We're not flipping or moving anything around. It's just everything's going right too. Okay, so my trapezoid is actually going to be starting over here. My triangle. So there, I think I got it moved to the right too. Solomon, you paying attention here? We good on that? All right, we got a couple of minutes. Let's look at graph practice 2, and we'll do a few of these. The next class we have, which is what? Oh, wait a minute.
Friday. Oh, wait, we don't have
Monday.
I see till Monday. Oh, Lord. Okay, the next class we have next Monday, we will have a quiz. Before we take the quiz, we'll do a practice. So just to get all the cobwebs out, and then we're gonna take the actual quiz, but it's gonna look like this. It's gonna be some random shape, which for graph practice 2, the shape is a little bit different. It's got the triangle, but then it's got this M thing. Alright, so there's my function. We're on graph practice 2. Gotta get a couple more practices in before you take off. So Lauren, front page here, 1 through 7, graph practice 2. What looks like a good problem to do on this page? 7? Okay, so wait a second, what's happening here? What's this? This is where I don't know how to say it, we mirror the right side, right? We lose the left and mirror the right. And then what does this do? Down 1. Okay, so Lauren, what that means is I'm going to draw my right side, that M shape. I'm going to draw it exactly as it is. And then I'm going to redraw it over here. So that takes care of this part. The absolute value of just x, you draw the right, then draw it on the left. And you lose whatever was over there to start with. Now we're going to take that picture and drop it down 1. So, Lauren, is this making sense to you?
Yeah.
Good. Does anybody else have an issue with this? And, oops, anybody have a question about the red being the final answer? Will Browning, pick one more. 1 through 7, except the one we just did. 3. So 3 says y equals f of x plus 1. So Will, what's happening in this problem?
Oh, left one.
Left 1. So no trickiness, take the original picture and move everything over to the left 1 space. So we gotta move this triangle, starts here. There's my triangle. Now I got my trapezoid, or my M thing. And that's it. That seems pretty easy. Shepherds, turn it over. 8 to 15, pick one. 11, oh Lord. There's lots going on in problem 11. Bryce, can you tell me what the negative in problem 11 does? What does the negative do? Just the negative. This is going to go upside down. But then, yes, you're right. The 3 is going to multiply the height. And then what does the plus 1 do, Bryce? Up 1. Very good. So, really, guys, if you can keep track of all that, you can draw this. Draw it in as many steps as you need. Wait a minute. I'm gonna draw it over here. do a good job. This will be our last one. Let's do a good job. So, I'm going to go ahead and see if I can flip it and times it by 3. All in one step. Okay. So if I flip this triangle and times it by 3, how tall will it be? I heard somebody say it. It's going to be 6 tall. Why is it going to be 6 tall? Because it's originally 2 tall, and I'm timesing it by 3. Now this guy's going to come down, to the upside down. He's 3 tall, 1, 2, 3, 4, 5, 6, 7, 8, so he's going all the way down to 9. So there he is. Everything flipped over and 3 times as tall. Now I'm going to pick it all up 1. That's easy. Do not panic. Just pick every point up 1. So here, here, here. Here's your triangle. Here, 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 here. Here's your W. Easy peasy. The purple is the final answer. Okay, so what happens next time we're together? We're going to have a quiz, and it's going to have like, just like the front of one of these. So I'm going to give you a shape, and you're going to have to do 4, 5, or 6 problems using all that. And we will practice before we do it. You might, since I don't see you for what, 5 days, you might work on these practice sheets a little bit. I'll just give you okay, so everybody knows that you got your graph practices, spend a little time on that.